Hello friends, welcome to UGC EPG Pathshala. I am Dr. Prabodh Kumar Mishra from Department of Geography, Shivaji College, University of Delhi, Delhi. Today I am going to elaborate upon frontogenesis processes, world pattern and associated weather, which comes under the paper Climatology. First of all, let us discuss what could be the learning outcomes of this module. While going through this module, you will be able to define fronts, identify the frontal zones, discuss characteristics of fronts, explain the classification of fronts, distinguish between cold and warm fronts, and describe the distribution of fronts over the globe and weather phenomena. Introduction. The literal meaning of the term front is the forward margin of something. It is a sort of boundary between two air bodies. These two bodies are quite different from each other. It is not always possible to find definite boundaries between two different air masses. More often, a gradual transition is observed for many kilometers. However, when one air mass moves rapidly into another, a distinct boundary becomes established. Such a boundary is called as front. Therefore, it can be stated that a narrow strip along two different bodies is generally termed as front. Another word, genesis, means beginning or method of formation of evolution of something. You must be aware that the air masses is divided into different groups based on different criteria. When two different bodies of air masses are coming into direct contact with each other, fronts are originated. Therefore, the process of the formation of front is known as frontogenesis. Frontogenesis is very commonly found in higher latitudes. They have evolved in unique pattern over the globe and have modified the weather of the area under their influence very significantly. Opposite to frontogenesis, there is a term called frontolysis, meaning the decaying of the fronts, the decaying of the fronts. In this module, an attempt is made to study the processes of the formation of fronts, their distribution, as well as associated weather conditions. Fronts are three-dimensional sloping boundary across which the horizontal gradients are sleek. In other words, fronts are defined as zone of mixing or discontinuity between two air masses. They have contrasting characteristics in terms of temperature, density, relative humidity, wind direction and pressure. Fronts are interface between cold and warm air masses intersecting along the temperature convergence zone or subtropical low, which helps maintaining latitudinal heat balance. Thus, it can be said that front is a line of discontinuity that represents the transitional zone between the two air masses having contrasting characteristics. Frontal surfaces separates these two contrasting air masses. The first real advancement of our understanding of mid-latitudinal weather variations was made with discovery of many day-to-day changes are associated with the formation and movement of boundaries or fronts between air masses. The term front was first proposed by a group of meteorologists which was led by Vidya-mitra, who was working in Norway during the First World War in 1918. The three meteorologists Vidya-mitra, L. Solberg and T. Bergeron are considered important for creating an in-depth knowledge and advancement of the fronts. Their ideas are still a very integral part of forecasting and weather analysis in the middle latitude and the high latitudes. Later in 1975, F. W. Cole defined front as an interface or transition zone between two air masses of different density. However, it should be noted that fronts are not only the transition zone between the two air masses of different density, the transition zone might also be of different temperature, humidity, wind direction and pressure. Frontal zones. Frontal zone is the vast transitional zone between two converging air masses. It depicts the discontinuity zone of opposing and contrasting air masses. Frontal zones are inclined at a very low angle towards the ground and are never parallel or vertical to the ground surface. Frontal zone is a dynamic and mobile zone, therefore, it drifts with prevailing winds. Frontogenesis. The term frontogenesis was introduced by T. Bergeron, Norwegian meteorologist, for describing the formation of new fronts. However, later the term was extended to include the processes of formation of both new fronts and the regeneration of the old and decaying fronts that already exist in the atmosphere. The region of frontogenesis represents the region that has the convergence of the contrasting air mass. On contrary, we use the term frontolysis means the destruction or dying of fronts. Hence, frontolysis is the opposite of frontogenesis. Fronts do not come into existence all of a sudden, rather they appear only after the process of frontogenesis has been in operation for quite some time. The act of weakening or vanishing of existing front is not accompanied suddenly. The process of frontolysis must continue for some time in order to destroy an existing front. Conditions for frontogenesis. When the distribution of frontogenesis was studied, it was noticed that the process does not occur everywhere. Frontogenesis requires certain characteristics for processes to occur. They are temperature difference. The two opposing air masses that converge to form a front must have a contrasting temperature. If one air mass is warm, moist and light, and the front cannot be created when the other air mass is cold, dry and dense. What happens when those two contrasting air masses converge? Air mass obviously invades the areas occupied by the warm and light air mass. As a result, the warm and light air mass is pushed upward and this generates a front. This also explains why no frontogenesis takes place in the equatorial region. Two air masses also converge at the equator, trade winds, but the temperature of both these air masses is uniform. So, the temperature difference is the missing factor here, because which no frontogenesis takes place at the equator. Convergence of air masses. In the very definition of frontogenesis, the word convergence has been used, and thus it is understood that it is the prerequisite for the frontogenesis processes. When the two air masses having different temperature converge, they try to invade the space of each other, and this leads to formation of fronts, development of fronts. When two contrasting air masses converge and spread horizontally along the axis of dilation, the probability of creation of fronts increases. However, there are other necessary conditions for the actual formation of the frontogenesis. When the convergence occurs, the formation of the fronts depends on the angle between the axis of dilation and the isotherms. Fronts are not formed when this angle is more than 450. Frontogenesis is only activated when the angle between the axis of dilation and isotherms decreases. Due to this decrease in angle, a point comes when the isotherms become almost parallel to the axis of dilation, and this is when the frontogenesis takes place. The intensity and steepness of the fronts depend on the temperature gradient of the two air masses. A stationary front is formed when convergence between two air masses parallel to each other occurs. In such a situation, no upward displacement of the air occurs. Such kind of stationary front does not result in cloud formation and precipitation. Stationary fronts are rarely found because a slope mostly occurs in the fronts due to Coriolis force. Frontolysis, dissipation of fronts. Frontal decay represents the final phase of a frontal existence. Although it is not necessarily linked with occlusion, when contrasting air masses lose their characteristics and differences, decay occurs. In other words, when the air masses move away from each other or when the temperature contrast between the adjacent air masses diminishes due to one region or another, the frontolysis takes place. The dissipation of fronts takes place in three ways. A. Through fronts stagnation over a similar surface. B. As a result of both the air masses, cold and warm, moving on parallel tracks at the same speed. 3. By the system entering air of the same temperature. Frontolysis happens in the areas of Siberia, Northern America, etc. Frontal characteristics. The character of frontal weather depends upon the vertical motion of air masses. If the air in the warm sector it is rising relative to the frontal zone, the fronts are very active and are termed anafronts. The term anafront describes boundaries which show instability, meaning air rises rapidly along and over the boundary to cause significant weather changes. Sinking to warm air relative to cold air masses gives rise to less intense catafronts. Catafront is weaker, bringing smaller changes in temperature and moisture as well as limited rainfall. Fronts may differ in their types, location or real extent, but the following characteristics are more or less common in all of them. Fronts are the zone of mixing of cold and warm air masses, and it covers certain areas. The area and extent which is covered by the fronts are vary in time and space, ranging from 3D boundary extending up to tropopause. Apart from areas, slope is one of the most important characteristics of the front. In general, cold fronts are steeper than warm fronts. The frontal slope depends upon latitudes of the front, wind speed and temperature difference between the air masses. Cold air always runs under the warm air. When the slope between the cold air always run under the warm air, when the slope between them is steep, the large vertical motion will occur because of the intense lifting of warm air masses. This will result in intense weather. The factors which are responsible for steeper slopes are large winds, velocity, difference between air masses, temperature difference and latitude. Isobar and isotherms develop kink bend in the frontal zone. Because of an abrupt change in pressure as well as pressure gradient across the front, the isobar while crossing it from a kink and always bends towards the direction of the low pressure. The wedge formed by the bending of isobar across a front always point towards the higher pressure. Mostly the fronts lie in the trough or low pressure. Temperature is the principal property used to identify air masses and fronts between them. Large differences in air temperature are recorded across a front, but the changes in temperature may be abrupt or gradual depending on the nature of opposing air masses. Further, the width of frontal transition zone is dependent on the temperature contrast between two air masses. Larger the difference in temperature, thinner the frontal zone, and vice versa. Fronts are always characterized by temperature inversion layer because of the warm air over a wedge or cold and dense air masses. Inversion of temperature is found in the frontal zone. Warm air override the cold air. Winds always blow from higher to lower pressure crossing the isobars at an acute angle, as wind moment is always controlled by pressure gradient and Coriolis force. It is therefore natural that an abrupt wind shift must occur at the fronts. On common parlance, it can be stated that sudden shift of the direction of wind is observed, that is, wind direction is not fixed. The frontal intensity is determined by the turbulence. Both turbulence and gustiness are required to make the front strong. Gustiness results into convective phenomena like strong winds and thunderstorms. Frontal activity is invariably associated with cloudiness and precipitation. Since warm air moves up along the frontal surface, it cools adiabatically, which results in cloudy condensation and precipitation. The type of clouds and precipitation falling from them depend on the slope of the front and the amount of moisture in descending mass of air. The weather condition is also affected by speed of the front. The rapidly moving fronts create intense weather conditions in comparison to slower moving fronts. Fronts are the agents of latitudinal exchange of heat and moisture, as frontal zone is mobile zone, therefore it drifts with prevailing winds. Fronts are favorable place for cyclogenesis and have generally a life cycle of 4 to 7 days. After that they start decaying. Classification of fronts. The types of fronts depends on the characteristics of the front, direction of the movement of the air mass, mechanism of frontogenesis and associated weather. Fronts are classified into 4 main types: the warm front, the cold front, the stationary front and the occluded front. Warm front. A warm front is that gentle sloping frontal belt along which the warm air moves over the area which has been occupied by the cold air, and the cold wedge present in the frontal zone retreats. The average slope of the warm front in the middle latitude is 1 is equal to 100 to 1 is equal to 400. The warm air that has risen above then cools down adiabatically, and then it becomes saturated and get condensed. Later it causes gentle precipitation in a large area for a long period of time. The frontal boundaries of such fronts has a very gentle slope. They move slowly and are less violent in nature in comparison to cold fronts. They may result in thunderstorm, but most of the time they are associated with stratiform of clouds that brings light to moderate rainfall. Before the arrival of such fronts, one can see the arrival of cirrus clouds, altostratus clouds, altocumulus clouds, and finally the stratus cloud and the fox. Cold front. A cold front is formed when a cold air mass in the frontal zone moves under the warm air mass. Along the slope of the front, the cold air gets active and it invades the territory of the warm air. The cold air, being the dense air, settles down and forces the warm air to uplift. The slope of cold front is 1:50 to 1:100. The weather condition associated with cold front is bad weather that brings with it thick clouds, heavy precipitation, thunderstorms and lightning. The slope of a cold front is much steeper than the warm front. These are fast moving fronts. It is associated with most violent kind of weather conditions. Also these cold fronts travel the farthest by maintaining its intensity. The arrival of cold front is marked by the arrival of cirrus cloud before them. The cold fronts are also associated with the squall lines, which are basically lines of thunderstorms that run parallel to and ahead of the fronts. Stationary front. Stationary fronts is formed when two air masses converges in a manner that they are parallel to each other. As a result of this parallel placement, no vertical movement of the air takes place in stationary fronts. It can be guessed from the name itself that stationary front neither travels forward nor backward. It remains stationary in its position. Their behavior is similar to warm air. Stationary fronts are formed rarely because due to Coriolis force. Most of the type of slope is created before the formation of a front. These fronts mostly occur over the ocean seas. Occluded front. It is earlier stated that cold front travels the fastest among all the fronts. Occluded fronts are created while traveling. The cold front overtakes the warm fronts and the warm air is totally displaced from the ground surface. The mature storm system is associated with it, and occluded front is further classified into two kinds of fronts. Cold occlusion fronts occurs when the cool air that is present behind the cold front is colder than the advancing cold air which is present ahead of the warm front. Such kind of occlusion can mostly be seen in North America. The occlusion occurs when the cold front forces itself under the warm fronts, and as a result that uplifts the warm fronts. Warm occlusion. Warm occlusion occurs when the air which is present behind the cold front is warmer than the advancing air which is present ahead of the warm front. In simpler terms, it can be understood as warm occlusion occurs when the cold air which is present behind the cold front is not dense enough to lift the cold air which is present ahead of the warm front. Here the retreating air overtakes the advancing air. It is uncommon to find warm occlusion in comparison to cold occlusion. World distribution pattern of fronts. Fronts are associated. Depressions tend to develop in a well defined order. The major regions for frontal development are the areas that are most frequently baroclinic as a result of air stream confluence. This is in case of East Asia and Eastern North America, especially in winter, where there is a sharp temperature gradient between the snow covered land and warm offshore currents. These zones are referred to as Pacific Arctic fronts formed along Rockies, Great Lakes regions, and Atlantic polar front formed when maritime tropical air masses meet continental polar air masses. Full development of this front takes place during winter respectively. Their position is quite variable, but they are displaced equatorward in winter when the Atlantic frontal zone may extend in the Gulf of Mexico. Here there is a mixing of different characteristics of air masses in terms of stability between subtropical high pressure cells. Depressions developing here commonly move northeastward. Frontal frequency is very high in North Atlantic, whereas it decreases eastward in the North Pacific because of less gradient of sea surface temperature. Frontal activity is also very common in central North Pacific. Another section of the polar front, commonly referred to as the Mediterranean front, located over the Mediterranean Caspian Sea areas, is formed when the cold polar air masses of Europe meet the winter air masses of North African origin over Mediterranean basin and initiate frontogenesis. The Atlantic Arctic front is formed when the maritime polar air masses meet the air masses developed along the boundary of Arctic source region. Associated weather of warm front. Warm front produces a variety of weather phenomena. The warm fronts with rising warm air has multi-layered clouds that thickens and lowers towards the surface position of the fronts. Clouds are deepest just north of the front. Clouds are deepest just north of the warm front boundary and progressively becomes thinner and higher towards the north. High wispy cirrus is present in the form of mare tails appear first, then progressively thick and lower clouds like cirrostratus, altostratus, nimbostratus appears as the front approaches. The sun is obscured as the altostratus layer thickens and drizzle begins to fall. The cloud often extends through most of the troposphere and with continuous precipitation occurring is generally designated as nimbostratus. The intensity of the precipitation depends on the stability of the warm air. It is generally light to moderately heavy and continues extending over a wider zone. If the warm air is conditionally unstable, thunderstorm may develop over a warm front. In addition, fogginess and poor visibility are very common in the precipitation area. At the passage of the warm front, the wind veers, the temperature rises and the fall of pressure is checked. If the temperature of the cold air is below freezing, snow, ice pellets or freezing rains may occur. As the front passes, an appreciable rise in temperature is observed. Associated weather with cold front. Cold front also produces a variety of weather conditions and phenomena that are equally variable depending upon the stability of the warm sector air and the vertical movement of the frontal zone. The classical cold front clouds are accompanied by cumulonimbus with vertical development and heavy showery precipitation. Over the British Isles, air in the warm sector is rarely unstable, so that nimbostratus occurs more frequently at the cold front. With the cold front, the cloud is generally stratocumulus and precipitation is light. With cold front, the precipitation is generally for a short period, but it is very heavy downpour. Many a times precipitation is accompanied by thunderstorms. In northern hemisphere, there will be a wind shift from a southerly to southwesterly direction to the northwest or north at its passage. With the passage of the cold front, the wind veers sharply and pressure begins to rise. There is a fall in temperature. A drop in temperature is expected after the passage of cold front. Within a few hours of passing the front, clearing of skies can be expected. Since the cold air mass moves over warmer ground, sufficiently instability may develop in its lower layer to produce a scattered shower. If the precipitation is snow, the combination of low temperature, strong winds and blowing snow along the following the cold front is called blizzard in North America and buran in Siberia. Summary and conclusion. The most significant and prime contribution was made by T. Bergeron with his team. He was the one who first proposed the term front for the first time. When two air masses with different physical properties meet due to effect of the converging atmospheric circulation, they do not merge readily. The transition zone of the layer of discontinuity so formed between two air masses is a three-dimensional surface called front. The fronts can be classified in four types, with cold, warm, occluded and stationary front. Warm front produces a variety of weather phenomena. The associated weather phenomena are different in each type of fronts. The cold fronts brings lots of precipitation and cold weather, whereas the warm front is the cold front brings lots of precipitation and cold weather, whereas the warm front brings drizzly, rain and warm weather. Stationary front is where they come together and they stay stationary or not moving. Fronts are associated depressions tend to develop in a well defined order. The major regions of frontal development are the areas that are most frequently baroclinic as a result of air stream confluence. The major areas for frontogenesis are Pacific Arctic regions, Atlantic polar regions and Mediterranean regions. Much is being studied about the fronts, but still we lack precision in forecast and associating their intensity. It is a process through which heat exchange takes place. Nowadays, availability of satellite imageries and data has helped in better understanding of frontogenesis. Fronts are of crucial importance in determining the well-being of human and society. Thank you very much.